Okay then, question 10 of chapter 6, Statistical Distribution, Stats and Mechanics, Year 1, AS book. Okay, so that doesn't help to pull that out. Let's see then. Question 10. State clearly the conditions under which it is appropriate to assume the random variable has a binomial distribution. Okay, so a couple of things with random ones. One, that there is a fixed number of independent trials. Okay, that there is a possibility of only success or failure, so i.e. it's a yes-no question. Failure. Okay. We've said that they're independence trials. We've said that they're a fixed number. The success probability is fixed or constant. Okay. That's about it. All right. So they've just got to be independent, fixed number of the trials. Okay. Success, failure. Done. Okay. B. Door-to-door salesman is trying to get people to have double glazing installed. Probability of him being success, okay, of success is 0.05. Okay. Find the probability that he will have at least 2 out of the first 10 houses. He will have at least 2 successes out of the first 10 houses he goes to. So we've got a binomial distribution. We have taken a sample of 10. We have a probability of success of 0.05. And we want to have a look at the probability that X will be 2, and it will be at least 2. So that means we want to have it to be, we can have 2, we can have 3, we can go all the way up to 10. Okay, but at least 2. So I want it to be greater than or equal to 2. Okay, so with that in mind, because it's greater than and equal to 2, we're including the 2 in our result. So when we do this going the other way with the greater than less than signal, we will be excluding the 2. So we'll be doing greater than or less than 1. Okay. Putting this in, where is a calculator? Here we go. So coming back on that. So number of trials in this case is 10, and probability is 5%. Okay. And looking at a probability scale here, we want to change it to a less than 1. We set, okay, and that's 0.91386, 0.91386, okay. I'm doing that on the calculator. 1 minus 0.91386. Okay, gives us 0.08614. 0.08614. Okay, don't need that bit in there. All right, so that's that. Now then, part C. Calculate the smallest number of houses he must canvass so that the probability of his getting at least one success is 0.99. So we've changed the distribution. Should probably use a different letter to X, but anyway. And the binomial now is, we don't know how many he's going to do, but we still know that it is 0.05. And we are looking for the probability that he has at least one success. So that means he can have 1, 2, 3, 4. So he is including 1. Okay, and he can have more than. So this is the same as the probability of 1 minus the probability of 0. Okay, not 0, but it's the same as the probability of x being equal to 0. Okay, and it needs to be put in for that. So it's going to be the 1 minus that. Okay, 1 minus the probability of x being less than equal to 0. Okay, which is basically equal to 0. And if we want it to be equal to 0, we are going to have the 0.95 raised to the power n. Okay. And yeah, and that needs to come through. So that's going to be less than, if we can get at least one success, is 0.99. It's equal to 0.99. So 1 minus equals 0.99. Okay, well now that we've got that, we can just solve it through. So bringing that across there, we end up with 0.01 is equal to 0.95 n, just rearranging the equation around. Okay, and then we can take the logs of both things. So we can do the log of 0.01 divided by the log of 0.95 will equal n. Okay, putting that into the calculator quickly then. 0.01 divided by the log of 0.95. Okay, and we get n as 89.78. So n, being whole numbers, is going to come up to 90 houses. So the gentleman will have to knock on 90 houses to guarantee at least one sale. Okay, good.